Okay, so for this example, we will be learning how to find a maximum volume. Okay, so this one is a very simple shape. It is like a cuboid. If you have a tissue paper box around you, you can visualize it as a tissue paper box. So of course, sometimes it may not come in this shape. It can come in a cylinder, it can come in a pyramid, okay, whatever shape that you can think of. Okay, so anyway, in this question, if you read this question and the description, most people will have issues with the 12 edges. So most of you may be confused, where are the 12 edges of a rectangular box? That's why I say if you have a tissue box around you, you can try looking for the 12 edges. So the 12 edges are made up of 4 heights. So there should be 4 heights. Okay, and there should be 4 length, and there should be 4 breadth. So these are where you get the 12 edges. Okay, so if you have a tissue box around you, you can visualize the 12 edges with this idea. So the 12 edges is forming, came from a piece of wire that is 540 centimeter long. So with the current information, you are supposed to express H in terms of X. So at the point when they ask you to express H in terms of X, all you know is the 12 edges. So obviously you got to use the 12 edges and the 540 to express H in terms of X. Okay, so you make use of 4 length. 4 length will be this. The 4 breadth will be 4X, and the 4 height will be 4H. So if you add up the 12 edges, there will be 540 centimeter. So you can work out the algebra. The working out of the algebra is very much like make X the subject. Okay, but in this case, we are making H the subject. So you might see that you actually get a big fraction, but you can simplify the fraction. So you can do a 540 divided by 4. Then you can do a 12x divided by 4. So that will be easier. So that's how you make H, express H in terms of X. Okay, the next one, we're going to be showing the volume. So the volume is length and breadth times height because the shape is a rectangular box. So obviously, if it's not a rectangular box, if it's a cylinder, then it will be pi r squared times height. Okay, whatever relevant mensuration formula. So in this case, I'm just doing a length and breadth times height. And because the expression that I will need to show is in terms of X, I will need to insert whatever my H is. Okay, the expression I show that you're supposed to show is in terms of X. So your H got to disappear. So that is why in the first part, they ask you to express H in terms of X. So insert the H that you have found and you do your normal expansion. Okay, that will be the volume. So at this point, if you can show the volume of the box, that means your part 1 will have been correct already. So you are kind of secured for part 1 and part 2. Okay, so subsequently, if you take a look, you already managed to get a volume in terms of one variable. Okay, then the next one, the question is saying, find the value of X for which V is stationary. So you got to recap the idea, the theory. What happens when V is stationary? So when V is stationary, dV dx has to be a 0. Okay, so know the theory first. Okay, then you go to the technical part. So use the expression that you have gotten in the second part. Do your normal dy dx. In this case, the dy dx is not even challenging. It's just a very simple bring down power minus power, which by now all of you should be okay. Okay, so for V is stationary, you can write out the definition. Write out the definition so that it guides you in the steps. So when you try to set dv dx equal to 0, it is a quadratic equation. So do your normal quadratic equation. Okay, solve for x as per normal. So when you get two values of x, okay, think about which one is irrelevant. X equal to 0 will be irrelevant because if x is 0, the whole box will just disappear. There will be no more length and breadth. So it's not a valid answer. So to answer the question, what is the value of x when b is stationary? This is the value of x. And you are going to calculate the value, what is the value of volume. So using this x value, you can calculate the volume. Return it back to the volume formula. So it's quite easy. So that will be the volume. And then the last part, your job is to determine whether is it a maximum or minimum volume. So this is the part where you're going to apply either your first derivative test or your second derivative test. So if you look at the first derivative, it's actually quite easy. It's actually quite easy for you to do a second derivative. So I will do a second derivative. So I'll be using the second derivative test. And I'm going to be testing the x equal to 30. The testing is like the stationary point. It's the same idea. So you differentiate a second time, you insert into the formula, and you get a negative value. So your second derivative return you a negative value. That means, right, the volume that you already obtained is a maximum volume. So that's how a full question is like. I will say this one is much easier. Okay, so look through the whole idea. So if the question never asks us to test, actually I won't be testing it. Okay, so for this one, we are finding the maximum volume.